Good morning.
Good morning, sir.
Good morning, sir.
Good morning. So next to look at the level 2 problems. So look at the first problem. So we have to find what? The range of the function f of x is equal to sine inverse x plus tan inverse x plus secant inverse x. So before finding range, first what we have to find? Domain. So what is the domain of this function? What will be the domain of this function? See, for sine inverse x, what is the domain? Closed interval minus 1, comma 1. For tan inverse x, what is the domain? All real numbers. For secant inverse x, what is the domain? All real numbers except the numbers between minus 1 and plus 1. That means minus infinity comma minus 1 union 1 comma infinity. Minus 1 plus 1 included. So for all these three intervals, what are the common points? What are the common points?
-1 and 1.
So minus 1 and 1. So remember, all the 6 trigonometric functions are defined only at minus 1 and plus 1 only. So then range contains f of 1 and f of minus 1. So first I'm calculating f of minus 1. Sine inverse of minus 1, what you'll get? Minus pi by 2. Tan inverse of minus 1, what you'll get? Minus pi by 4. Secant inverse of minus 1, what you'll get? Pi. So thus f of minus 1 is pi by 4. Next to f of 1. So f of 1, what you'll get? Sine inverse 1, pi by 2. Tan inverse 1, pi by 4. Secant inverse 1, 0. Because secant 0 is 1. So 3 pi by 4. So this range contains two elements, pi by 4 and 3 pi by 4. So in the same way, try this problem. So what is the domain and a range of f of x is equal to sine inverse x plus cos inverse x plus tan inverse x plus cot inverse x plus secant inverse x plus cosecant inverse x. So what will be the domain? You can say easily now.
-1, 1.
Minus 1, comma 1. And what will be the range? You can say easily. What is sine inverse x plus cos inverse x?
Pi by 2.
And for these values of x also it is defined. Because here all the 6 functions are defined. Okay. And tan inverse x plus cot inverse x is what?
Pi by 2. So
And
3
secant
pi by 2.
inverse x plus cosecant inverse x is what? Pi
Pi
by
by
2. So pi by 2 plus pi by 2 plus pi by 2, what will you get? 3 pi by 2. So here f of x is a constant function. So range contains only this element. So write down. So did you copy?
Yes, sir.
So second problem you can easily solve now. So what is given? The value of tan of sine inverse 3 by 5 plus tan inverse 2 by 3. So you take this is A, first angle, and second angle is B. So then we have to find tan of A plus B. That is tan A plus tan B by 1 minus tan A tan B. So where capital A is equal to sine inverse 3 by 5 and capital B is equal to tan inverse 2 by 3. So from this tan B is equal to what we'll get? 2 by 3. And from this sine A is equal to what we'll get? 3 by 5. So to get tan A value, just draw the right angle triangle corresponding to angle A. The sine A 3 by 5 is opposite is 3, hypotenuse is 5. So adjacent side will be 4. So from this triangle, what you'll get tan A value? 3 by 4. So substitute here. Tan A value how much? 3 by 4. Tan B value 2 by 3 by 1 minus 3 by 4 into 2 by 3. So numerator LCM is what? 12. So 3 3s are 9, 4 2s are 8. So denominator also don't cancel here 3 3. Okay. Take LCM is 12. So 4 3s are 12. So 12 1s are 12 minus 3 into 2, 6. So 12 12 cancel. So 9 plus 8, 17 by 12 minus 6, 6. So 17 by 6 is the answer. So like that, third and fourth you can able to solve it. So in fifth, I'm going to give hint. So what do you have to substitute? X value, tan theta. So LHS, you convert it into simplest form. Then after that, you equate it to pi by 45. Okay, same problem, tan inverse of root 1 plus x square minus 1 by x. We have in our PU also. In PU also we have that. Okay. Right. So did you copy second one?
Yes, sir.
So next, you look at the seventh question. So the smallest and largest values of tan inverse 1 minus x by 1 plus x where 0 less than or equal to x less than or equal to 1. So let it be y. Let y is equal to, so tan inverse of 1 minus x by 1 plus x. And here the domain of this function they have taken restricted to 0 to 1. Then in this interval we have to find its maximum value and minimum value. Anyway, y is what? Y is a continuous function and tan inverse of something is always increasing function. Okay, but here we have to check because of here minus x is there, we have to check whether it is increasing or decreasing. Okay, so here I'm using this one. I'm going to convert it into simplest form first. Then after based upon the sign of the tan inverse x, so it may be either increasing function or decreasing function. Suppose if tan inverse x coefficient is positive, so basically tan inverse increasing, so y also increase. If tan inverse x coefficient negative, so tan inverse x is basically increased. So minus tan inverse x will be decreasing. So first I'm going to convert it into simplest form. So given function is in the form of tan inverse x minus y by 1 plus xy. So which can be written as tan inverse x minus tan inverse y. And this will be possible if x into y is greater than minus 1. And here x into y is nothing but here x is nothing but 1, y is nothing but x. So x into y is nothing but x. X into y is nothing but x. So tell me whether x greater than minus 1 satisfies? Yes. Because according to the question, x takes the values from 0 to 1. If it takes any value from 0 to 1, obviously those values are greater than minus 1. Excuse me. So we can use this formula here. So y is equal to, simplest form will be what? Tan inverse 1 minus tan inverse x. So y is equal to tan inverse 1 is pi by 4 minus tan inverse x. So it is a decreasing function. Is decreasing function on closed interval 0, okay, not only on closed interval 0, 1, in any interval it is decreasing only. So particularly given interval. So obviously you will get the maximum value of y at 0. So if you put x value 0, what you will get? Tan inverse of 0 is 0. So you will get the maximum value of the function is pi by 4. And the minimum value of the function will come at 1. So pi by 4 minus tan inverse 1. So pi by 4 minus pi by 4, which is 0. So minimum value 0, maximum value pi by 4. The smallest value is 0 and the largest value is pi by 4. Right on? Did you copy?
Yes, sir. Copied.
Yeah. Next, look at the 8th one. So all possible values of P and Q for which cos inverse of root P plus cos inverse of root of 1 minus p plus plus cos inverse of root of 1 minus q is equal to 3 pi by 4. So clearly, given equation is meaningful if 0 less than or equal to root p less than or equal to 1. So the square root function cannot be negative, so don't take minus 1 to 1. Okay. So 0 less than or equal to root 1 minus p less than or equal to 1. And 0 less than or equal to root 1 minus q less than or equal to 1. So from this, we will get 0 less than or equal to p less than or equal to 1. So from this, we will get 0 less than or equal to 1 minus p less than or equal to 1. So after simplifying this again, you will get 0 less than or equal to p less than or equal to 1. And here if you square, what you will get 0 less than or equal to 1 minus q less than or equal to 1. So after simplifying, we'll get 0 less than or equal to q less than or equal to 1. So thus, this equation is meaningful when p and q both lie between 0 and 1. And whatever we are getting the values right now for p and q, so those values must satisfy these inequalities. So those values only we have to consider the solutions. So now cos inverse of root p plus cos inverse of root of 1 minus p. P I am writing root p whole square. And similarly, q I am writing 1 minus root q whole square is equal to 3 pi by 4. So we can write cos inverse x can be written as cos inverse root of 1 minus x square. Cos inverse root of 1 minus x square can be written as sine inverse x when x is positive. Even at 0 also it is valid. So when x is positive means x must be lie between what? 0 and 1. Even at 0 also it is valid. So now cos inverse root p as it is, and cos inverse root of 1 minus root p whole square is look like cos inverse root of 1 minus x square. So this can be written as sine inverse of root p plus this is sine inverse of root q is equal to 3 pi by 4. Now cos inverse root p plus sine inverse root p is nothing but pi by 2 plus sine inverse of root q is equal to 3 pi by 4. So thus sine inverse of root q is equal to 3 pi by 4 minus pi by 2, which is pi by 4. So root q is equal to sine pi by 4. So what is sine pi by 4 value? 1 by root 2. So root q is 1 by root 2 means q is equal to how much? 1 by 2. So here answer is not depending on p. So p may be any number from 0 to 1 and q will be equal to 1 by 2. Okay. So this the values of p and q are p must be lie between 0 to 1 and q must be equal to 1 by 2. Right now. You copied? Did you copy?
Yes, sir.
So in ninth question, just you write sine inverse x is pi by 2 minus cos inverse x. Anyway, cos inverse root 3 by 2 is pi by 6. Now you can find easily x value. So you will get either unique solution or no solution. Okay. Next, you look at the 10th question. So what they're asking, the value of x that's satisfying sine inverse x plus sine inverse 1 minus x is equal to cos inverse x. So you do one thing, you just verify the options. Okay. If you put x value 0, sine inverse 0, 0. Sine inverse 1 minus 0, sine inverse 1, pi by 2. Cos inverse 0, pi by 2. So x value 0 satisfying. Next, you put x value 1 by 2. So because next we are 1 minus 1 also there. Okay. So first if you put 1 by 2. If you put 1 by 2, so sine inverse 1 by 2, pi by 6. Sine inverse 1 minus 1 by 2 means sine inverse 1 by 2, pi by 6. Cos inverse 1 by 2, pi by 3. So even that is also satisfying. But x is equal to 1 not satisfies. Because sine inverse 1 is pi by 2. Sine inverse 1 minus 1, sine inverse 0 is 0. And cos inverse 1 is 0. So not satisfying. Even minus 1 also not satisfies because for x is equal to minus 1, here 1 minus x becomes what? Pi. Sine inverse 2. Sine inverse of 2 is not defined. So just verify the options so that you will get x value 0 and x value 1 by 2. But the same question, if they ask number of solutions, then you must have to solve the equation. Then how we can approach? Tell me. So we'll do one thing here. You write sine inverse 1 minus x is equal to cos inverse x minus sine inverse x. Cos inverse x minus sine inverse x. And this one, if you write pi by 2 minus cos inverse 1 minus x, is it useful? And this is cos inverse x. And if you write pi by 2 plus cos inverse x. So pi by 2, if you take this side, what you get? Pi minus cos inverse 1 minus x is equal to 2 cos inverse x. Apply both sides cos function. So cos of pi minus cos inverse 1 minus x is equal to cos of 2 cos inverse x. So cos of 180 minus theta minus cos theta. So this is, if you treat this is like theta, so then this is a cos to theta. Cos to theta formula is what? 2 cos square theta minus 1. So here I'm putting theta is equal to cos inverse x. So that x value, what I will get? Cos theta. So now cos to theta value 2 cos square theta means 2x square minus 1. So minus cos of cos inverse 1 minus x is 1 minus x, which is equal to 2x square minus 1. So further, 1 minus x, minus of 1 minus x, if we transfer right side, it become what? 2x square minus 1 plus 1 minus x is equal to 0. So plus 1 minus 1 cancel. So if you take x common, 2x minus 1 will come. So that x value 0 and x value 1 by 2. Then just to verify, after getting these values, if you verify, so both are valid. Okay. So clearly, x is equal to 0, x is equal to 1 by 2 satisfies given equation. So if there's number of solutions, so those number of solutions is 2. 2 solutions are there, 0 and 1 by 2. But here they're asking what are the solutions. In such case, better verify the options instead of doing this But if they ask number of solutions, you must have to approach this method. Right on. So do you copy? Did you copy them?
Yes, sir.
So next look at 11th question. So this is the what miscellaneous exercise problem, actually NCERT textbook problem. Sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. So this can be written as, for the minus 2 sine inverse x can be written as pi by 2 minus sine inverse of 1 minus x. And pi by 2 minus sine inverse of 1 minus x is nothing but cos inverse 1 minus x. And if you take cos inverse, if you apply cos on both sides, or if you take cos inverse this side, it become what? Cos of minus 2 sine inverse x. So which is equal to 1 minus x. So cos of minus theta is cos theta. So you'll get cos of 2 sine inverse x. So here you take sine inverse x is equal to theta. Then what you'll get x value? Sine theta. So that this will be cos 2 theta. So cos 2 theta in terms of sine, because here x value sine theta. So that's why I'm writing cos 2 theta in terms of sine theta. So in terms of sine theta is what? 1 minus 2 sine square theta. Sine square theta is nothing but what? X square is equal to 1 minus x. So 1 cancel. So what do you get? Minus 2x square plus x is equal to 0. If you take x common, what do you get? X into 1 minus 2x is equal to 0. So x value 0 or x value 1 by 2. So just verify whether among 0 and 1 by 2, which one is satisfies or both are satisfies. If I put 0, verification, just a verification. So if I put x value 0, then what I will get? LHS sine inverse 1 minus 0, pi by 2, minus 2 into sine inverse 0 is 0, is equal to pi by 2. So satisfies. If I put x value 1 by 2, sine inverse 1 minus 1 by 2 is sine inverse 1 by 2, which is pi by 6. So 2 into sine inverse 1 by 2 is pi by 6, which is equal to pi by 2, is wrong. Therefore, x is equal to 0 is only solution. So thus number of solutions of the equation is 1. So they are asking number of solutions. Don't get confused. They are not asking the solution value. They're asking number of solutions. So don't put option A. So option B is correct answer. So even here, if you want, you can find the domain of this equation. So here 1 minus x should be lie between -1 and +1. And x must be lie between -1 and +1. Because sine inverse x defined when x is lie between -1 and 1. Sine inverse 1 minus x is defined when 1 minus x lie between -1 and 1. Then here, if you multiply with minus, so still that is lie between -1 and 1, adding 1, then what you'll get? 0 less than or equal to x less than or equal to 2. So thus the common domain is what? 0 to 1. The common domain. So that means this equation is meaningful when x is lie between 0 to 1. And we have to find the particular value of x satisfying the given equation. And we got that that solution is x is equal to 0. So did you copy?
Yes, sir.
So next to 12th question, just use tan inverse x plus tan inverse y formula. Then remove the tan inverse. You will get a quadratic. After solving the equation, you will get x value 3 and x value -2 by 3. But x value -2 by 3 not satisfies. Because if x value -2 by 3 to substitute, LHS is a negative angle, whereas RHS is a positive angle. So that's why -2 by 3 is not valid. Only x is equal to 3 is the valid. So thus number of solutions is 1. Next to question number 14. So we have to find the sum of the squares of all the solutions of the equation 2 sine inverse of x plus 2 is equal to cos inverse of x plus 3. So clearly this is meaningful when x plus 2 and x plus 3 both are lie between -1 and +1. So that is -3 less than or equal to x less than or equal to -1. And subtracting here 3, -4 less than or equal to x less than or equal to -2. So this what is the common area? -3 and -2. Common intersection is what? -3 to -2. So that means after solving this equation, whatever the solutions we got in between -3 and -2, that is only valid first. Okay. And in those also we have to verify whether it satisfies the equation or not. So we can rewrite this equation as cos of 2 sine inverse of x plus 2 is equal to x plus 3. So now same thing, if you take this is the theta. So let theta is equal to sine inverse of x plus 2. Then sine of theta is equal to what we'll get? X plus 2. Then here LHS is what? Cos 2 theta. Cos 2 theta in terms of sine theta is what? 1 minus 2 sine square theta. Sine square theta means what we'll get? X plus 2 whole square is equal to x plus 3. Or this can be written as 2 into x plus 2 whole square plus x plus 3 minus 1. So 2 into x plus 2 whole square plus x plus 2 is equal to 0. So if you take x plus 2 common, in both terms x plus 2 common, then what you'll get? 2 into x plus 2 plus 1 is equal to 0. So that means what you'll get? Either x is equal to minus 2 or x is equal to minus 5 by 2. Because 2x plus 4 plus 1. So 2x plus 5, x is equal to minus 5 by 2. So minus 2 minus 5.5 by 2 we got. So we have to verify among these two which option will satisfy. So if you put x is equal to minus 2, LHS what will get? 2 into sine inverse 0. Sine inverse 0 is 0. And RHS what will get? Minus 2 plus 3, 1. Cos inverse 1, 0. So satisfies. Next two, if you put x is equal to minus 5 by 2, LHS is what? Negative angle. RHS is a positive angle. So LHS what will get? 2 into sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2 is minus 5 by 6. If you put x value minus 5 by 2 in RHS, then what will you get? Cos inverse of 1 by 2, which is 5 by 3. So not a valid solution. So therefore, x is equal to minus 2 is only solution. But we have to find what? It's a square. So therefore, x square value what? 4. Because we have to find sum of the squares of all the solutions. Here we have only one solution. Then sum of the squares of all solutions is nothing but square of that solution. And square of that solution is what? 4. So did you copy?
Yes, sir.
So next, look at the 20th problem. So what is the value of tan inverse 1 by root 2 minus tan inverse of root of 5 minus 2 root 6 divided by 1 plus root 6. So you can use tan inverse x minus tan inverse y formula. You will get that out. You will get the answer. But better you try to simplify this argument, second function argument. So square root of 5 minus 2 root 6 can be written as square root of So 5 can be written as root 3 whole square plus root 2 whole square. And as root 6 can be written as root 3 into root 2. So if you observe clearly, it is in the form of a square plus b square minus 2ab. So that can be written as what? A minus b whole square. So root 3 is more than root 2. So you write root 3 minus root 2 whole square. So square root get cancelled. What will get? Root 3 minus root 2. So tan inverse 1 by root 2 minus tan inverse. So root of 5 minus 2 root 6 can be written as root 3 minus root 2 divided by 1 plus root 6. So that root 6 I can write root 3 into root 2. So tan inverse 1 by root 2 minus. So it is look like tan inverse of x minus y by 1 plus xy. So which can be written as tan inverse x minus tan inverse y. So further tan inverse 1 by root 2 can be written as what? Cot inverse root 2 minus tan inverse root 3 minus into minus plus tan inverse root 2. So that this tan inverse root 2 plus cot inverse root 2 can be written as what? Pi by 2 minus tan inverse root 3. So tan of which angle is root 3? Pi by 3. So tan inverse root 3 will be what? Pi by 3. So pi by 2 minus pi by 3 is equal to what? Pi by 6. 90 minus 60 is 30. So thus the answer is pi by 6. Right. Will you copy 20?
Yes, sir.
So look at the 21. So we have to find the range of the function f of x is equal to cot inverse x plus secant inverse x plus cosecant inverse x. So first you find domain. So what is the domain of this cot inverse x? All real numbers. Secant inverse x, all real numbers except the numbers between -1 and 1. Or you can write it is equivalent to minus infinity comma minus 1 union 1 comma infinity. So these two are one and only same. Okay. Intersection r minus open interval minus 1 comma 1. So this intersection of all these three sets is what? R minus open interval minus 1 comma 1. Now in this interval, f of x is equal to what you'll get? Secant inverse x plus cosecant inverse x become what? Pi by 2 plus cot inverse x. So here x is clearly a real number and x doesn't belongs to open interval minus 1 comma 1. Nothing but x belongs to r minus open interval minus 1 comma 1. Suppose if x takes all real numbers, then the range of cot inverse x will be open interval 0 comma pi. But here x is not taking all real values. It is not taking the values from -1 between -1 and 1. So then the range of cot inverse x cannot be taken as 0 to pi. So it will be also reduced. The size of range of cot inverse x also decreases because of domain of cot inverse x here. Domain of f of x is not all real numbers. Okay. So as x doesn't belongs to open interval -1 comma 1, then cot inverse x is decreasing function. So cot inverse x doesn't belongs to cot inverse 1 comma cot inverse -1. So that is cot inverse x doesn't belongs to cot inverse 1 is pi by 4 and cot inverse -1 is 3 pi by 4. So as x belongs to r minus open interval -1 comma 1, now cot inverse x belongs to what? Open interval 0 comma pi except pi 0 comma pi except these values. So 0 to pi is the original range. So in that we have to remove pi by 4 to 3 pi by 4 part. So if I remove this part, what is the remaining? 0 to pi by 4. Pi by 4 is including union 3 pi by 4 to pi. 3 pi by 4 also including. Okay. So now adding pi by 2 because to get range of f of x, because f of x range is what? Pi by 2 plus cot inverse x. So just add pi by 2. Okay. So then f of x is equal to pi by 2 plus cot inverse x belongs to, just add pi by 2. Pi by 2 plus 0, what you'll get? Pi by 2, comma, pi by 2 plus pi by 4, what you'll get? 3 pi by 4, union, pi by 2 plus 3 pi by 4, what you'll get? 5 pi by 4, comma, pi by 2 plus pi, what you'll get? 3 pi by 2. So this will be the range of f of x. Right. Any doubts? Any doubts?
No, sir. Understood.
So do you copy?
Yes, sir.
Next, look at the question number 22. So in 22, first you adjust cos 7 pi by 5. So cos 7 pi by 5 can be written as cos of 5 plus 2 pi by 5. Because the other angle is in terms of 2 pi by 5, no? So that's why I'm reducing 7 pi by 5 angle. Now cos 180 plus theta is what? Minus cos theta. So thus the LHS given function will be what? Cos inverse of 1 by root 2 into cos 7 pi by 5 can be written as minus cos 2 pi by 5 and minus sine 2 pi by 5 as it is. Okay. So if you take minus out, then what you'll get? Cos inverse of minus 1 by root 2 into cos of 2 pi by 5 plus sine of 2 pi by 5. So it is look like cos inverse of minus x. So that can be written as pi minus cos inverse x. Okay, now multiply with the 1 by root 2. So cos inverse of 1 by root 2 into cos 2 pi by 5 plus 1 by root 2 into sine 2 pi by 5. So 1 by root 2 can be written as what? Cos 45 or sine 45. Okay. So I'm writing it as first term I'm writing 1 by root 2 cos 45. This is cos 2 pi by 5 as it is. And this 1 by root I'm writing sine 45 and sine 2 pi by 5 as it is. So now this can be written as pi minus cos inverse of cos of a minus b. But we have to take a minus b means pi by 4 minus 2 pi by 5 or 2 pi by 5 minus pi by 4. So the range of cos inverse do not containing negative angles. So you have to take pi by 4 minus 2 pi by 5 or 2 pi by 5 minus pi by 4 according to whichever is positive. So here 2 pi by 5 minus pi by 4 is positive angle. So that's why you write this as cos of a minus b means cos of 2 pi by 5 minus pi by 4. So pi minus cos inverse of cos theta can be written as theta. Now because this theta is belongs to closed interval 0, 5, that is positive angle. So 2 pi by 5 minus pi by 4. So pi minus 2 pi by 5 minus into minus plus pi by 4. So what is the LCM? 20 will be the LCM. So what will you get? 20 pi minus 8 pi plus 5 pi. So it is equal to what will you get? 12 plus 5, 17 pi by 20. So the answer is 17 pi by 20. Right on. Did you copy?
Yes, sir.
So in 23rd, just I'm giving hint. So just write arc cot x. Nothing but cot inverse x is pi by 2 minus tan inverse x. Okay, similarly, arc cot x plus 2, you write pi by 2 minus tan inverse of x plus 2. So that it will be reduced to tan inverse x minus tan inverse y formula. So use tan inverse x minus tan inverse y formula, apply tan on both sides. Then you will get a quadratic in x. So on solving the equation, you will get two, maybe you may get two roots and find the sum of those two roots. And after getting the roots, just you verify which roots or which root is satisfying. Okay, suppose you got alpha and beta, two roots. Alpha is not satisfying, beta is not satisfying, then sum of the roots means alpha only. If both are satisfying, then alpha plus beta is the sum of the roots. Okay, so 24 already we did similar model problem. So 26 already I gave this hint. So here it is given what? Sine inverse 5 by x plus sine inverse 12 by x is equal to what is given? Pi by 2.